Okay, so today we're dealing with or tackling potential divider. Now, this is a circuit that I think you're familiar with for sure. And we have two resistors and one light bulb. Now, as you can see, we have two resistors with the same resistance. Now, I just want you to just quickly observe as I vary the resistance. Observe the light bulb, virtual light bulb. So observe the virtual brightness and see how the brightness actually varies when I increase the resistance and when I decrease the resistance. How does the virtual brightness vary? Well, let's try that one more time. And decreasing the resistance. Right. Now, that tells you that the resistance will affect the potential difference across. So the potential difference across will be affected by whether the resistance of this increase or decrease, correct? Because they're sharing the voltage. So the two resistors are actually sharing the 9 volt. And when the potential difference across the resistor is affected, the potential difference across the bulb will also be affected. So that means the voltage across will also be affected, and therefore the brightness will be affected because the current going through would actually be different, right? Now let's change over to a voltmeter for a better, a number sense of what's happening. Okay, let's put the voltmeter here, and we're gonna put this here. Right. So as you can see, when the resistance is the same, the two resistors have the same resistance, the voltmeter shows 4.5 volt, which means it's half of 9 volt. So they're sharing equally. Now what happens when I actually vary this resistance again? So it's kind of obvious, right? It tallies with what we understood about the brightness of the bulb. So as we increase the resistance, the potential difference across the resistor increases. As we decrease it, the potential difference decreases. Now, this is useful because, for example, if I don't really need the entire 9 volt of the battery, and I'm not able to get a battery that is 5 volts or a 6 volt battery, but I just need a 6 volt, right? So what happens is that by just using this circuit, and I vary the resistance to the point whereby I get a voltage of 6 volt, just nice over here, then I can connect my appliance or my component there to get the voltage that I want. So that's why we call it potential divider. That means, or we call it voltage divider. So that means we are dividing the 9 volt into parts by using the ratio of the resistors, the resistance, and so that we can use the part that we are interested in or we need. Now, how does this look like when we are calculating? So I drew a circuit that looks pretty similar to what we did earlier. Instead of a bulb or a voltmeter, I have put this as output voltage. So the value of the output voltage can be written as the ratio of R2 to the total resistance multiplied by EMF. So as you can see, it's kind of like the ratio of the resistance to the R2 to the total and the output voltage to the EMF, which is the total voltage supplied to the circuit. Now, another way of looking at it, I'm going to show you this, then you realize that this formula is nothing new at all. Okay, so you can see that EMF divided by R1 plus R2. So it looks like this, which is EMF divided by R1 plus R2. And you can see this part is actually your I. The I that flows through the circuit that flows through your resistance. Right. So you can see, but it's just that putting it this way, we are looking at the output voltage like a ratio of the resistance rather than being focused on the current. So it gives us a different perspective. And I hope this makes sense. Okay. Now, one of the students have ever asked me, so if you connect a component, for example, whatever, like a bulb or something, across the out to get the output voltage, wouldn't it affect, because it will draw current, maybe there will be current flowing through the bulb, and this formula no longer, holds true. I said this is a very good point. And normally, this potential divider circuit is used more in the electronics. So usually we'll connect electronic component rather than the electrical component like a resistor or something. So usually it is connected to electronics component that requires a voltage to turn on, but it doesn't draw current. So it doesn't work like the usual electrical component. So basically, if I want, say, like a 6 volt here, right? So basically the ratio of the R2 to R1 it will be adjusted so that I get 6 volts, and the electronics will just get 6 volts to be turned on, rather than, so it will not really draw current. So usually we don't always use the normal light bulb. So that's why it doesn't really draw the current that will affect the circuit. And not only that, just to highlight that the R2, the resistor, may not always be a resistor. The R1 and R2 may not always be resistors. We can use things like your light dependent resistor. Okay, we can use things like thermistor, which varies according to temperature, or we can use a rheostat, stuff like that, instead of the R1 or instead of R2. So basically, these components can be used in place of R1 or in place of R2. Okay, well, I think it'll be clearer when we get to the questions. Right, thank you.